Welcome so much to this lesson. We're going to continue with Mathematics Paper 2, the Crescendo Joint Examination. It's an exam which has been done by several schools. We have already discussed a good portion of the paper. If you have not been in touch, kindly get to our program, that is a Shifting Grades Online School, and search Crescendo Joint Examination. And for this paper, you will be able to see the whole of section 1, number 1 all the way to number 16, up to this point. Then a portion of the section 2 has already been uploaded. That is from number 17 all the way to number 20. So in this case now, we'll be beginning from number 21, which is a question on arithmetic sequences and series, together with geometric sequences and series. In other words, sequences and series. So this is what we'll be discussing. I invite you for the next 1 hour or so, and I am sure that you're going to learn something. Remember, our consultation line is 07 07 04 15 33 66. The same line is also our M-Pesa line. You can use the same to support our programs as you continue learning. Remember our program here, whereby you people can acquire airtime for any network from your M-Pesa, whereby you just have to go to the M-Pesa, Lipa na M-Pesa option. Then the pay bill number is what has been displayed here, 737356. Then the account is the phone number that you're purchasing the airtime for, be it Safaricom, Airtel, Telcom. Just enter the line, the line number 0704 153366, for example. Then after that, you proceed with the amount and you purchase your airtime. The airtime shall reflect instantly. It's good for you to remember that you can even purchase for a friend, whereby you use the same pay bill, but now the account number is the phone number of the particular friend that you'd like to purchase airtime for. Yeah. So utilize the facility and invite friends to the same. Back to the program now. Number 21, an arithmetic progression at the first term A and the common difference as D. Write in terms of A and D, the third term, the 9th term, and the 25th terms of the progression. We know generally that any of the term is usually given by A plus N minus 1 multiplied by the common difference. So when we talk about the third number shall be A, which is the first term, plus N, which is 3, minus 1. Then this will be multiplied by unknown common difference. So the third number shall be A plus 2 by D. Then we are talking about the 9th term. So the 9th shall be A plus N, which is 9, minus 1 by the common difference. So this shall be A plus 8 multiplied by the value of D. And finally, the 25th term, which will be A plus 25 minus 1 multiplied by D. This shall be A plus 24 multiplied by the common difference. That way. Look at part B. The progression is increasing, and the 3rd, 9th, and the 25th terms of the first 3 consecutive terms. Sorry, I think there is some misinformation here. The progression is increasing. Then we are told the 3rd, the 9th, and the 25th terms of the first 3, or form the first 3 consecutive terms of a geometric sequence. Now, the progression which we have here, which is arithmetic, is increasing. That means this progression is having a positive common difference. This progression is having a positive value of D. That is what it means by increasing. So the above progression is increasing, and the terms that we have listed, the third, which is here, the 9th, which is here, and the 25th, which is here, form the first 3 consecutive terms of a geometric series, which is also a progression. If the sum of the 7th term and twice the 6th term of the arithmetic progression is if the sum of the 7th term and twice the 6th term of the arithmetic progression is 78, calculate part 1, the first term and the common difference of the progression. So there is a lot of information here which we are supposed to interpret. One is that these 3 terms are consecutive in a geometric progression. So we have to say that in case we take, this becomes the first now, this becomes the second for the progression, then this becomes the third in that particular progression. So we will say now, in case we take the second term, which is A plus 8D, then we divide by the first one, which is A plus 2D. We're supposed to get the same as when we take the third, divide by the second. This interpretation comes from a simple analogy. Let's say, for example, we have a GP, whereby the first term is 2, then the second one is 6, then the third one is 18, then the third one is 54, fourth one like that. It means in case we get 6 divided by 2, we get the same as when we take 18 divided by 6, and this will also give us the same as when we take 54 over 18. In all the cases, we can get a common ratio of 3. So there is a common ratio which relates this term, the second, and the third that way. So from this, we can form an equation, whereby I can begin by, let me first divide my space. Okay, so I can start by doing what? Cross multiplication. A plus 8D multiplied by the same, which means squared. Then A plus 2D, A plus 24D, that way. Now with this, we can expand so that we may, we are interpreting the first information so that we go to the second sentence here. So here we will have A squared plus 16AD plus 64D squared. This is equal to, when we expand the right-hand side, we'll take A times everything in the second bracket. So it will be A squared plus 24AD. Then this we have to add. When we take 2D and we multiply by everything in the second bracket, that will be 2AD plus 48D squared. Now with this, we can group terms. A squared, because of the 2 sides, A squared, when we group with A squared, it will cancel. Then we can talk about AD now. Whereby we are having 16AD. Then here we have 24 and 2AD. So we're already having 26AD. And we can bring 16 to this side, whereby 16 will be subtracted from 26. And that will give us exactly 10AD. This will be the same as when we take 64 minus 48. This is giving us 16D squared. So I'm taking 64 minus 48. I also group the D squareds together. From this, we can get the first simple equation, whereby the value of A can be expressed. You know, from here we can divide through by D such that 10A equals to 16D. And from this we can say the value of A equals to 1.6, the value of D. And this we can call equation 1. So we have broken it down until A equals to 1.6 D. Let's get to the second information. If the sum of the seventh term and twice the sixth term of the arithmetic progression is 78. Arithmetic is the previous one now. So the seventh term will be given by A plus 6D. Now, when we add, that is the seventh term, when we add twice the sixth term, so twice the sixth term, twice the sixth term, we're supposed to get 78. So the sixth term is A plus 5D. So this is A plus 6D plus 2A plus 10D equivalent to 78. So we can group a few terms here, whereby we will be having 3A plus 16D equals to 78. Yeah, this is a simple equation, so we can call it our equation 2. I don't think we can simplify it further. But now from equation 1, you see we said the value of A equals to 1.6D. So we can now work with 1.6D instead of A plus 16D equals to 78. Then 3 multiplied by 1.6, this is giving us 4.8. D plus 16D equals to 78. You know, from now we can first get what we are calling the value of D by talking of 20.8 equals to 78. And the value of D shall be, when I take 78 and I divide by 20.8, I'm getting 3.75. 3.75. That is the value of the common difference. Remember, we are finding the first term and the common difference. So the first term A, which is here, A is given by 1.6, the value of D, which is 3.75. So the value of A shall be, this is exactly 6. For the arithmetic progression. We are done now. That is fully solved, but it is really some instruction which required informed interpretations. So you have to follow keenly, listen keenly, take some notes, solve it together with me. Don't just rush to the question. Okay. The last 3 marks now. The sum of the first 9 terms of the AP. 9 terms of the AP. So with A is 6 and a common difference of 3.75, we can talk about the 9th term. The 9th term shall be, I know we need the sum, but allow me get the 9th term first, which needs A plus 9 minus 1 into the common difference. So 9th term shall be 6 plus 8 multiplied by 3.75. This shall be 36. So the 9th term is 36. So sum of a given number of terms in arithmetic progressions is usually given by, when we take a n over 2 into 2a plus n minus 1 multiplied by d. Let me use the curly brackets there. Or the sum can be given by n over 2 into the first term plus the last term, that way. So in the first option, we can take n we need the sum of 9 terms. So 9 over 2 into 2 multiplied by A, 2 multiplied by A plus N, which is 9 multiplied by D, and D is 3.75. Yeah, that way. So we can compute the answer here. I need to take 9 minus 1, which is 8 multiplied by 3.75, which is 30. Is that so? Yeah. Then 30, we are supposed to add 12 to get 42. Then we multiply by 9 over 2. So 9 over 2 is giving us 189. 189. Look at the second option now, whereby we are saying we can simply take n out of 2 multiplied by the first term plus the last term. So when 42 is multiplied by 9 over 2, we get 189. So any option here can work for us. Either this formula or this one, it will lead us to the same sum for the first 9 terms. Thank you so much for following that one keenly. Remember, consultation line 0704153366. That way, please use that line for consultations and also to acquire some revision materials. 22, complete the table below to 2 decimal places. That is a very serious instruction for the function y equals to 2 the sine of x plus the cosine of half x. Then the range is between 0 and 306. We have intervals of 30 from 0 to 30 to 60 to 90, and so on. Okay. So that is what we'll be doing now. So we have to go to the table and discover that it is a bit detailed and broken down, so that when we take 2 multiplied by the cosine of x, which is 0 for this particular case, cosine of 0, we'll get 0. 2 multiplied by sine 30, we get exactly 1. 2 multiplied by sine 60, we get 1 point. Oh, we have been taught to 2 decimal places. We should obey instructions to the latter. So this shall be 0.00 to stick to the instructions. So 1.00, sorry for that. Then the sine of 60 will be 1.73. The sine of 90, so 2 sine 90, in other words, shall be exactly 2, so 2.00. 2 sine 120, that will give us 1.73. Then when we have 2 sine 150, we get exactly 1, so it should be 0.00. 2 sine 180, that gives us 0, so 0.00. 2 multiplied by the sine of 210, that should give us negative 1.00. Then 2 multiplied by sine 240, negative 1.73. Remember, you're just using your calculator. Actually, in filling these tables, when it comes to graphical work, there is no reasoning. It's just being very careful. No a lot of work. You just pick your calculator and you write 2 sine 270. That will be negative 2. So negative 2.00. Then 2 sine 300, negative 1.73. Then 2 sine 300, negative 1. So it should be 0.00. Then finally, this becomes 0.00. Then we proceed select the second option. The cosine of half x. So cos half of 0, is just 0. So cosine of 0 is 1. So 1.00. Cosine of 15, 0.97. Cosine of 60, which is cosine of half of 60, which is 30. That should be 0.87. Then we have cosine of 45, which is 0.71. Cosine of 120. Cosine of half of 120 is 60. So cos 60 should be 0.5. So we write it as 0.50. Then cosine of 75, that is half of 150, 0.26. Then the cosine of 90, the half of 180, which is 0.00. The cosine of 105, half of 210, that will be negative 0.26. Then half of 240 is 120. So cos 120, that will give us negative 0.5. So 50. Then the half of 270, which is 135. So we need cos 135, which is going to be negative 0.71. Then we have cosine of 150, which is equivalent to negative 0.87. Then cos the half of 330 is exactly 165. So cosine of 165, that will be negative 0.97. Then finally, we are talking about the cosine of 180, which is 1.00. So that's how, 1.00. Negative 1.00. Negative 1.00. Sorry for that. Half of 360 is 1. So cosine of 180 is a negative. Write it very keenly. Negative 1.00. So negative. So we should be keen, very keen actually. So now we have all that. The value of y is given by when we take 2 sin x plus the cosine of half x. So we have to take 2 cos x, we add for us to get the value of y. So in the first case, we will have 1.00. The second case, when we add, we get 1.97. Then here we get 2.6. So 2.60. Then 2.71. Then 2.23. Then we will have 1.26. Then we'll have 0.00. Then this is when we add these negatives now, we get negative 1.16. Negative 1.26. Then we can talk about negative 2.23. Then we'll talk about negative 2.71. Then we talk about negative 2.6. Then we'll be having negative 1.97. And finally, negative 1.00. That is it. So we have all the values now. A matter of just using a calculator and you are there. So our marks are already intact. The next thing is to plot using a scale of 1 centimeter to represent 30 on the X. Then 2 centimeters to represent 1 unit on the wire. Draw the graph. Let me first apply the scale. That is the y-axis. Then we can have the x-axis here. That way. Then we can talk about the scale now. Whereby from 0, we can talk about 2 centimeters, 1 unit. So we expect 1 to be here. 2 centimeters to represent 1 unit. Yeah. So 1, 2 means if we continue here, 3 will be at a point there. Then we will have -1, -2, -3. With on this other side now, 1 centimeter is supposed to represent 30. So 30, 60, 90, plus 30, 120, 150, 180, 210, 240, 270, 300, 330, 360, 390, like that. Yeah, so we can now plot now that we have the scale. We can do some plotting. Allow me to use black to identify the coordinates. So we have y and x. So 0 goes with 1.00. So 0 goes with 1. So 0, 1, which means we begin at this point. Then we can also talk about 30, 1.97. That goes with 1.97, which means, let's say 2, because we can only plot 1 decimal place. Then we have 60, which goes with 2.6. 2.6, which is here. The next is 90, which goes with 2.7. 90 with the 2.7. 2.7. 120 goes with 2.2. So 2.2 is here. The next is 150. 150 is going with 1.3. 150 with the 1.3. So 1.3 shall be here. 180. 180 goes with 0.0. So 180 shall be at that point. When we go to 210, we'll talk of -1.3. So -1.3 shall be here. Then 240, we need -2.2. -2.2. 270, this goes with -2.7. -2.7, which is at this point, yeah, -2.7. Then when we talk about 300, 300 goes with -2.6. -2.6, the point is here. 330 goes with -1.9, which is almost at 2. Yeah, approximated 2, exactly 2. And finally, 360 will be plotted against -1.00, which is here. So now we have the points already plotted, and they are suggesting a very smooth curve. So we can now plot this curve. Allow me to use a different ink. There is a green, yeah. So I want to come up with this curve now. Remember, curve is supposed to be very smooth. Very smooth. When at the turning points, you're supposed to be very careful. Very careful. Yeah, that way. So we got the curve down. A very excellent curve. You can try your curve and compare it with what I'm coming up with here. It's a very smooth curve. I've used my free ant, not a program that can be used to do this. They are there, but for this case, I've used my free ant. So look at the name of the curve now. This curve y equals to curve y equals to 2 sin x plus the cosine of half the value of x. So I have named my curve also. That is it. My curve is named. All right. Now from that point, we can proceed to respond now to a few questions after this curve. Part C. Find the value of x for which the function reaches its maximum point. So at maximum points, that is the highest point possible. The highest point possible for the curve. Highest point possible for this curve. We look at the value there. So at the highest point, which is that should be the turning point now. At the turning point, which is at 90. I think that is at 90. Yeah, so the value of x at the highest point is 90. It's 90. So we have to look at the highest point. Okay, the highest point is slightly before 90. You see, at 90, we are already turning downwards. We're already curving downwards. So we can look at the curve at a point which is the highest, just before 90. Because at 90, we are already curving downwards. So which value will be there? For this axis, we are supposed to interpret the scale and say 5 small units are representing 30 degrees. What about 1 small unit? It will be 30 by 1 over 5, and this gives us 6. So 6 units. So we talk of 6. This is 66. 66. When we add 6 again, we get 72. Then we talk of 78. Yeah. Yeah. So 60 plus 6. 60 plus 6 gives us a 66. Then 72. Then 78. So it is at 78. At 78. I hope I have done that relation very well. I hope I've done it very well. When I take 30 over 5, yeah, 6 units. 6 units. Therefore, we are talking about 60 plus 18, which is 78. So the value of x is 78. degrees that way. Use your graph to solve 2 into 2 sin x plus cosine of half x. We can divide through by these two so that we have 2 sin x plus the cosine of half x being half or being 0.5 after dividing through by 2. So over 2 over 2. Yeah, so we get this. So this function, we need, this is the value of y. So we need when y equals to 0.5. What are the values of x when y equals to 0.5? When y is 0.5, what are the values of y? What is the value of y? So you move along the curve this way until you read the value there. So what will be the value of x there? You read from 150, we are adding 1, 2, 3, which is a 3 by 6 units, 18. So from 150, we are adding 18, and that will be 168. Yeah, 168. So the value of x equals to 168 degrees. That is it. 168 degrees. That one is done. Number 23. A good question on a probability. In a driving school, a trainee has to pass through 3 sets of traffic lights. The probability that she will have a stop at any of the given lights is 2 out of 5. Draw a tree diagram to represent the above information. Therefore, we have a trainee who is a lady here. She will pass through a stop for green lights, and they must be 3. Then the probability of stopping is 2 out of 5. So for the 3, which are independent, we can start with the first one. Stopping is 2 over 5, which means not stopping is 3 over 5, because stopping and not stopping are mutually exclusive events, and their probability should add up to 1. In the second, we can have a stop or no stop. This one is independent, so the probability is 2 over 5, and not stopping, 3 over 5. Then on the other side, we talk about the same. Stopping, not stopping. So stopping is 2 over 5, not stopping, 3 out of 5. And finally, in the third one, we can have stopping or not stopping. Stopping taking 2 over 5, as usual. Then not stopping, 3 over 5. Then we proceed again to this bracket, stopping, not stopping. So 2 over 5, then 3 over 5. We proceed to this fourth bracket, the third, stop, not stop. So 2 over 5, then 3 over 5. And finally here, we'll talk about stopping, not stopping. So stopping is 2 over 5, not stopping, 3 over 5. So with this, we can outline all the outcomes at the end of the bracket. For you to have an easier time of interpreting the questions, after this, you can have the outcomes listed there. So from the first bracket here, we can talk about stopping, stopping, stopping. Then in the second one here, stopping, stopping, not stopping. Then third case here, stopping, not stopping, stopping. Then in the fourth one, we have a stopping, not stopping, not stopping. Then here, we can have a not stopping, stopping, stopping. Then here, not stopping, stopping, not stopping. Then at this point, not stopping, not stopping, stopping. And finally, we have stopping in all of them that way. So we outline how is the bracket ending with S. You get back up to the origin of the tree diagram until you outline all the outcomes like that. So we have the sample space now clearly outlined. Using the tree diagram or otherwise, determine the probability that the trainee will have to stop at only 2 sets flight. At only 2. Stopping at only 2. Stopping at only 2. Let me change my color here. Stopping at only 2 means this is one of them. This is another one. Stopping at only 2. This is another one. Stopping at only 2. Yeah, those are the cases. So stopping at only 2 can be stopping, stopping, then not stopping, which means stopping, stopping, and not stopping. Stopping, stopping, then not stopping. Or the second case, stopping, not stopping, then stopping. So stopping, not stopping, then stopping again. So that is stopping twice. Or we can have not stopping, then stops in the other two. That way. So this is the probability. One is the probability, and we can work it out. So 12 over 125 3 times. So 12 over 125 or means addition in probability. 12 over 125 or 12 over 125. So the answer settles us that 6 over 125. Yeah. That way. The part 2 of this question, we are determining the probability that the trainee will pass at least one set of flight without stopping. At least one without stopping. So if we're talking about at least one without stopping, then it means all these probabilities, at least one without stopping. It is all at least passing one without stopping. It means all these options. So it is only one case where he will stop in all of them. But now passing at least one without stopping. So we only have one case to exclude here, whereby he doesn't stop in all of them. And now, to have it easier done, we can just have that one minus that one particular case, 1 minus probability stopping in all of them, so that we may get the probability of the remaining options. So 1 minus stopping in all of them stopping in all of them. 1 minus 8 over 125. And this will give us 117 over 125. That is the probability. Now we have a different question here, which is our part C. A bag contains 3 white and 5 blue balls. A second bag contains 4 white and 6 blue balls. A ball is chosen at random from each bag. Find the probability that both balls are white. Both balls are white. Then again, find probability that both balls are of different colors. So in this case, we are not picking a bag. We are just picking a ball deliberately. So from bag A, we want to choose a white ball. So white from bag A, probability, picking white from the first bag, 3 out of a total of 8. Then in the second case, probability, picking white from bag B, it's going to be 4 out of a total of 4 and 6, which is 10. So we need now probability that they are both going to be. So it's probability white from A and probability white from B. So when we talk about and in probability, we're supposed to multiply. So 3 over 8 by 4 over 10. And this is going to simplify to 3 over 20. 3 out of 20. Part B. Both balls are of different colors. Okay. Now when you talk about different colors, now, we mean we can pick a from bag A, we can pick white from bag A, then we pick the other color, which is red. Apart from white, we're having a blue, sorry. Or we pick blue from B. Yeah. White from A and blue from B. That is different colors. Or it can be probability. We pick blue from A, then, we pick white from the B, the second option. Yeah, that way. So white from A takes a probability of 3 out of 8, and picking a blue from B is 6 over 10. Or means addition. Picking blue from A, and you know blue from A is 5 over 8. And white from the second bag, which is 4 over 10. 4 over 10. I really hope that you people are understanding this language of probability, because now I'll be having 18 over 80. Then I should add 20 over 80. This is 19 over 40. 19 out of 40. 19 out of 40, that way. Number 24, which is the last in this case. In the trapezium shown below, PQ equals to 3 times ST. Then T divides SR. T divides SR in the ratio 4:1. All right, that must be a mistake. That must be a mistake, because when we talk about 4:1, that means an internal divider. But I hope this one they wanted to write, yeah, 4:1, so that it becomes an external division. 4:1, that way. Or they would have used the word externally in the ratio. Then U is the midpoint. This U now is the midpoint of QT. Yeah. PU and QR intersect at X. As we can see, at X, then we're told that PX equals to H, PX equals to H, PU, and X, QX equals to K, QR. Okay. Given that PQ equals to Q, from P to Q equals to vector Q, as we can see, then P to S equals to vector P. Express QR in terms of P and Q. First of all, it's good for us to know that when we say that ST, okay, when we say PQ is Q, then this is equivalent to 3 multiplied by SR. Then it means the whole of ST, the whole of vector ST is a third Q. So that when multiplied by 3 now, we get PQ that way. So the whole of ST is that way. Yeah, that way. Then when we interpret the ratio of 4:1, it means from S to T, we have 4 proportions. Then from T back to R, we have only 1 proportion. So 1, 3, that way. Yeah, 1, 3. Express QR. So let me get to QR now. QR. So from Q to R, we can have QP. From Q to R, we can talk of QP plus P, S. Is it S? Yeah, then S to R. S to R. So here we can talk about Q to P should be negative Q. Negative Q. Then we add PS, which is a P. Then we add SR. Now the value of SR should be 3 out of 4. 3 out of the 4 proportions of 3 out of the 4 proportions of a third Q. Third Q. So let me check what to get here now. So I'll be having negative Q plus P, then plus a quarter Q. Yeah, a quarter Q. So we can begin with this vector being P, the negative Q plus a quarter Q, it becomes negative 3/4 vector Q. That way. Negative 3/4 vector Q. Yeah, such a thing. What about the other vector that we're supposed to express? Px in terms of P, Q, and H. Px in terms of PQ and H. PQ and H. Now for us to incorporate H, it means we have to pass through PU. We have to pass through PU. Therefore, we have to talk about PX being H. PX being H. PU. Then we talk about now H. And we talk about vector PU. So what will be vector PU? Vector PU, which depends on the ratio or on the route that we are going to follow. The route that we're going to follow. So for us to get PU, we can move this way from P to X to Q, then Q to U. P to Q, then Q to U. That way. Then we talk about H into vector Q plus Q to U, because U is midpoint, then that is half of QT. Half of QT. So half of QT. That means, again, we have to know what QT is. So this is a H into Q plus half. What about vector QT now? So vector QT should be Q to P. We move now backwards. Q to P, P to S, Q to P, P to S, S to T. Yeah, that is QT now. That way. So let's talk about H into Q plus half into. When we talk about QP, we mean the reverse of Q. Then we have to add PS, which is P. Then we have to add a third of Q, which is the value of ST. Yeah, that way. Then with this now, we can group a few terms together. That should be after opening a few brackets once again. So let me bring it up here. Okay, H into Q plus, now that becomes a negative definitely. So we will have negative half Q, then plus half P, then plus 1/6 Q. Yes, that way. At that point now, allow me group terms now. So we are still having our H at this point. Then now we multiply Q minus half Q. That becomes half. So half Q plus a sixth. So I should talk about half plus a sixth. So half plus a sixth. This gives us 2/3 of Q. So 2/3 of Q. Then we have now plus a half P. Yeah, that way. Then with this, we can open the brackets by multiplying by Q. So 2/3 by multiplying by H, vector Q plus a half by H, vector P. That way. So that is the expression of, that is the expression of the expression of Px, the first expression of Px. What about the second expression of Px? So for the second expression of Px, we are supposed to accommodate K. So PQ and K, constant K. So how shall we accommodate K? By ensuring that we go through QX. So we talk about PX. We talk about PX. PX being equal to PQ, then QX. So that's how we can get another way of getting PX. So PQ plus QX. PQ plus QX. So with this now we can say PQ is a vector Q, right? Yeah, vector Q. Then QX, instead of QX now we write QX equals to K QR. K multiplied by QR. And QR was calculated in part A. Was calculated in part A, which is P minus 3/4 of Q. P minus 3/4 Q. That way. So we can have Q plus K multiplied by P minus 3/4 K multiplied by Q. So with this, we can group the terms in this vector, which are having common vectors like Px equals to Q, P equals to Q, Q equals to P, Q equals to Q, Q equals to P, Q equals to Q, 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 Q equals to minus 3/4 of k q plus k p. At this point, we can factor out the vector q and have 1 3/4 k into vector q plus k multiplied by vector p. So we have our second expression. Yeah, our second expression for vector px. Now this is the first expression. This one is now the second expression. So that we go to part D, which says, hence, obtain the values of h and k. For us to get those constants, we have to say that the first expression is giving us px. The second expression is also giving us px. So we can equate the coefficients of corresponding vectors, like coefficients of q in equation 1 is 2/3 h. So 2/3 h, which is the coefficient here, should be the same as the coefficient of q in the other expression, which is 1 minus 3/4 of k. Yeah, which is the coefficient of q in the second expression that way. So from this, we can find, we can express now, or we can call it equation 1. Let me call it Roman 1 because we're already having 1. Then now we do another equation relating the coefficients of vector p. So from equation 1, the coefficients of p is half h. So half h equals to the coefficient of p in the second, which is just k. So this is equals to k, equation Roman 2. Now with the two equations, we can solve them simultaneously and say, if the value of k equals to half h, then equation 1 can be written 2/3 h equals to 1 minus 3/4. Instead of k, we talk about half h that way. So this is 2/3 h equals to 1 minus 3/8 h. Then when we start grouping terms together now, at that point, we will have to remain with 1 here. Then we take 2/3 plus 3/8. So 2/3 plus 3/8. 2/3 plus 3/8. And this gives us 1 and 1/24. 1 and 1/24 h. So that will remain with h. Now we have to divide through by 1 and 1/24. So when we do that, we are getting 25/24. 24/25, that is. That is the value of h, which means the value of k shall be half 24/25, giving us 12 out of 25. 12 out of 25. So that is it. We have the values now. Okay, of h and k. And finally, determine the ratio in which x divides qr. X divides qr. X divides qr. So we need to know which constant relates these two. So we know that qx equals to k, and remember constant k is 12/25 of qr. Yeah, that way. So from q to x, we get 12 proportions out of the 25 proportions of q to r, which means if it's out of 25, then we remain with a 13 here. I'm trying to interpret this relationship. Qx, so from q to x is 12 out of 25 qr, and qr is from here to the end here where there is r. So if we have 12 proportions out of 25, it means the other side there is 13. So that we talk of the total proportions, which are 25. So now the ratio of Rx to XQ is 13 is to 12. But now we need the ratio in which X divides QR. So X is dividing QR in the ratio 12 is to 13. That is the answer. 12 is to 13. In case you'd been told the ratio in which X divides RQ, then we would have talked about 13 is to 12. So direction is very important when we are talking about vectors. But for this case, we just wanted the answer at that point. Thank you so much for following, subscribe, and share.